This is the panel you've been waiting for. We already have decided amongst ourselves we are hashtag not boring, and this is not going to be AI bingo. So if you've got those cards out on the Agent Agentic bingo, put them away because we're going to bring you new, novel, exciting, and practical stuff that you can take to the bank, no pun intended. Okay. So the run of panel is going to be that we're going to briefly introduce our incredible panelists, lightning round. They're going to let you know in a sentence or so who they are and what they do. And to appropriately set the context, what does or does not agent or agentic mean to them? Because that actually is going to be important in the context of what we're going to be talking about. The bulk of the conversation will be around tangible use cases, practical stuff, lessons learned, citing specifics. So you're going to hear directly from them in terms of, some real things you can take home, back to your product and engineering teams. And then the final piece is going to be not just the lessons learned question, but had you known something very tangible in the last 12 months, what would you have done differently to build better, build faster, and create better pace to value? So that's what we're going to bring to you today. All right? So we're going to kick it off. Sir, 1 minute, go.
Great to be with you. I look after our applied AI in practice. In a nutshell, really is going after high-value problem statements, at the end of the day, that matter for our clients and the firm. And look, a big part of it is really how we actually empower the entire firm. So this is really about unlocking value. So enablement program, that means from access to providing the learning resources and state-of-the-art capabilities to the entire firm so we can go after it. Agentic system, look, it's been said, right? At the end of the day, AI is a system that can learn, reason, and act. When you're thinking about agentic, it's having some level of autonomy, so you can actually, select the tools, select the resources that it needs actually to, execute the task that you give it in hand. So it's really, we see it as a continuum, not necessarily, something, completely new.
Awesome. Gabe.
Thanks for hosting me today. I'm Gabe. I'm the CEO and co-founder of Rogo. We're building AI agents for financial institutions, for the front office of investment banks and investment firms. We serve about 100 different investment banks and investment firms across the globe. Raised $100 million from JPMorgan, Thrive, Khosla, a number of other great investors. And what we do is we sit financial experts side by side with researchers, and we work on creating tools that provide value today and build towards the future we're all envisioning, where these tools actually transform the way we work completely. What I consider an agentic system is taking LLMs, which in many ways are just the most ingenious brains we've ever had access to. They're smarter than me, they know more about most subjects, they have more processing power, more memory, and giving them agency, allowing them to take action in the real world, to use tools to plan and to pursue goals while they learn on the fly. And the story of agents over the next 5 years, I think, is taking LLMs and making sure that they can actually ramp the way a new hire does at an investment bank with those same tools in that same context.
So you can't spell agent without agency. Think about that one. Okay.
Deep.
Sir.
Hi, everyone. Honored to be here. Matt Glickman, CEO, co-founder of Genesis Computing. Genesis is the platform, the agentic platform that automates and accelerates data engineering. We've been at this for about a year and a half. And unlike other kind of waves, AI is basically being adopted faster in financial services and healthcare, two of the most regulated industries, versus media and others that typically were the first to go at this. Before starting Genesis, led product early on at Snowflake and helped grow our go-to-market in financial services. And then prior to that, spent an entire lifetime in financial services running data platforms for the front office for Goldman Sachs for just missed the 25-year anniversary, the dinner, which is actually a thing. As far as agents, and again, I'll start off with a little bit of controversy here. Agents are not digital workers. I think this is the kind of thing that is tripping people up in our experience is we're overthinking this and making this harder. Agentic technology is, I'd say, more equivalent to a transistor or a GPU as a capability, a very special capability that allows us to create thinking machines that we can embed in systems to accomplish things that were not possible before. I think it makes it much simpler to think about it that way. The second piece of controversy I'll throw out there, and I welcome my panelists to kind of...
That's a long definition of agent. Just
It's worth something. As far as, a lot of the conversation today has been about when to adopt AI, which use cases are good agentic or AI use cases. And I think that's exactly the reverse way to think about this, right? This wave is happening, right? Powered by the geopolitical forces that Alexandra and others mentioned today. So every decision should be similar to how Jamie from JPMorgan said, by default, 5 days a week in the office. Similarly, by default, the answer should be, can this be done with AI? Not, is this an AI-capable use case? Why shouldn't it be done with AI? So we can take advantage of the wave when it happens.
Okay. Manuela.
Okay, I'm going just to answer the introduction. So I'm Manuela Veloso, and I actually spent most of my life in academia at Carnegie Mellon University. Since 1986, I lived in Pittsburgh, and then literally I came to JPMorganChase in 2018 to head a group on AI research, trying to see how much AI could eventually or disrupt an industry that was not born digital. And in that sense, that's what brought me to this, was the curiosity to try to understand these not born digital. Before this, I did a lot of autonomous robots. I did lots of teams of robots, and all of them trying to pursue tasks. I'll answer better the question about agents when you'll ask me eventually. Are you going to ask me now?
Go now.
Okay.
So Manuela,
Mela, what do you
tell us what you're thinking about agents.
So I was in, I lived through the first times when the term agent was used. It's 1990, I believe, and Alan Newell at Carnegie Mellon. Maybe it was used before, but that's what we remember. He picked up this piece of chalk, and he went to the board, and he wrote perception, and a box, cognition, and a box, action, and a box, agents. And basically the reason why this was introduced like this was because the field of AI was all broken into pieces. People who do natural language, people who do machine vision, people who do some kind of planning and some kind of robotics. And it was all little things. And somehow the idea of the agent was indeed the putting all of these together, the ability to process data, be it with images, be it with text, the ability to use whatever was processed from that data to reason about a task, to try to see search, heuristics, trying to understand how to solve the task, and eventually to act. These perception, cognition, and action took place in terms of career for many people in robotics, because robotics do need the perception, do need the cognition, and do need the action. And then some colleagues of mine went to the University of Washington, and in the 92 they introduced soft bots, which were these digital agents. But they didn't go as far as the actual robot agents. So magically now we all talk about agents. But I think that just to come back to now, I think that what I view that it could be a contribution for all of us, for all to think, is that agents in one way need to be able to perform more than one task. So they are a bunch of skills. They are a bunch of ability to have things you can use to do this task, or you can use to do another task, and the reasoner tries to match whatever actions can be done to achieve a task. So my one thing that I would like to recommend everybody to think about is that when you think about an agent, think about the skills of the agent independently from the task immediately. Otherwise, you start writing it in terms of the sequence of the steps. You try to rush writing the code to solve the task rather than abstracting what this agent is all about. And it could be, it reads a file, it writes into a file, it can look at this, it can look at that. So it's a discipline of thought. You should try to identify all these little pieces. And then, indeed, comes a task, and you put these little pieces together. You optimize which ones are better, how much does it cost to ask this agent for the value of this number, and then you produce a plan. and eventually that thing gets executed. But try to embrace that an agent is not only like that task. If you cannot have your agent solve more than one task, maybe you are not there yet as an agent.
Okay. Good. An agent deficiency. Got it. Okay.
And is it to answer the question about the humans also? No.
Not yet. But
I think that's coming though.
But we can't wait for when I do.
Okay. I'm done.
Get ready. It's coming. Okay. But before we get there, I know you're all eagerly anticipating that one. Mike, you have at BNY a platform called Eliza.
That's right.
And to stoke a little bit of I guess, friendly banter between you and Matt, Eliza is in the business per se of building and/or manufacturing digital employees. Tell us more about that, and then Matt can tell you why it's not doing that, and then we'd love to hear your response to that.
Sure thing. Look, I mean, at the end of the day,
it's Eliza?
it really is.
The name is Eliza?
It is.
It is Eliza, yes.
Cheating. Because Eliza was Eliza.
That's where they picked it.
Yeah, we have a couple of angles in terms of why we named it Eliza.
Are there any trademark attorneys in there?
Eliza was this kind of initial dialogue system.
That's right.
In the 80s or something.
It also happens to be Eliza Hamilton, wife of Alexander Hamilton, who founded BNY. So that's a little bit of history.
Thanks.
Well played, sir. Well played.
So,
Well played.
I let it go.
I think what she really meant to say is, why isn't it called Manuela? But that's just between you and me. But go ahead. Keep going.
Eliza.
look, so you said it. Like, I mean, yeah, definitely we'll take a different view in terms of why it's not a digital employee. I mean, one way, it's a construct. Of course, at the end of the day, what problem is it solving that we care about, right? Like, and so we do have, why we're excited about this, it's not a concept anymore. We actually have these in production. If you think of, for instance, what it takes to onboard a new client, you need to do a whole slew of research. And that research takes hours, right? Like, I mean, now, if you have an agent that can actually take on that responsibility and, use the tools at its disposal to actually do that research, and the stuff that used to take you, 16 hours can be done in 10 minutes, that really makes a big difference. So we're quite excited. We're a platform company at the end of the day. BNY is a platform company that, touches 20% of the world's investable assets. So we see the potential of actually really creating the capacity that allows us actually to do more with what we have. So we look at things that we do at high volume. We also are a large payment processor, right? Like, I mean, processing nearly $3 trillion worth of payment every single day. So a small fraction of that, if it's not, needs to be validated, now agents are actually doing that. Or they're helping us actually remedy code vulnerabilities as well. So things that you need to do at high volume that really actually is providing value, but you don't necessarily need to guide it every step of the way. So you can actually give it a role, it has an identity, it has access to systems, and within that construct, it can actually has the degrees of freedom to actually go and execute these tasks. So so we're quite excited about it.
Good. I guess, and I do want to go to the point around the description of what they are doing. At the end of the day, these skills and tasks combining to have an outcome, are we, and I'm sure all of you in your organizations can relate to this, are we drowning ourselves in taxonomy? Are we really trying to struggle to describe a thing as opposed to really focus on kind of the core foundational enablers to achieve an outcome? So whether it's an employee or not, whether it's an agent or not, at the end of the day, it's, I don't want to say less about what we call it, but more about, building an end-to-end system or framework that allows for an outcome. So are we in the land of semantics here, or is there truly actually a difference?
No, I think it is an important, I wouldn't dwell on it too much, but again, I agree with you. I think focus on the outcomes, focus on we have a new tool as it is, that a thinking machine that can take these complex actions, can handle multiple skills, but I don't think you need a taxonomy for it. I think it's just basically treat it as we have a new kind of capability that we can put into these systems that can automate things that were hard to automate before. I do think one of the opportunities that it does present is the ability and sort of the excuse to extract out the knowledge that's the organizational knowledge that's not written down in the employees' brains today or dispersed amongst an organization's brains, or the connections of, I know Mary can do this part, Bob can do this part, I can kind of connect the pieces together. So that piece of the worker collective brain is actually the more important thing to embrace. And I would encourage you all to kind of think about all of your workflows that potentially could be automated. What are the things that are not written down that, whatever the taxonomy is, you can use this thinking machine's rollout as the excuse to extract out this knowledge that's hidden in disparate people's brains and encode it into a system for particular use cases. Like you said, customer onboarding. Today, right, this dispersed pieces of knowledge and systems and how the systems come together to accomplish that. Which is a liability, honestly, because now if one of those people in that organization were to leave, right, it's a disruption. Versus if all that knowledge or more of that knowledge could now be encoded in systems into these artificial brain systems, now you've taken what was a liability and you've turned it into an asset that could now be leveraged, be reasoned about, and that this kind of agentic technology gives us an opportunity to do.
Okay. Gabe, turning to you. You have a front row seat in the sense that your company is working and partnering very closely with many organizations, financial services. Building on what's been said in terms of this range of user persona archetype from junior to senior, okay? How are you seeing it actually playing out with your product? The product market fit, between a junior persona and a senior persona. Is there a gap? Is this fundamentally about institutional semantic knowledge? Is it fundamentally an operating model question? Like, what are you seeing in terms of product market fit for these use cases, either at the more senior level or at the junior level?
Yeah, I'm going to circle back to what Matt and Manuela said before addressing that, because I think it's so important. Manuela described her problem at JPMorgan as taking a non-digital institution and helping it solve digital problems. And I think the problem every institution will have over the next decade is going from a business that's predicated on people, enterprise value in their people, in your investors and your bankers, into a software and an AI business. As you teach your AI systems how to think the way that your people do, as Matt was saying, how do you capture that voiceover knowledge, that knowledge up here, and put it into a software system that you can leverage in perpetuity? And so in that roadmap, we're still early days, right? You have an intern, you're teaching that intern how you think, how you think about modeling, how you think about creating PowerPoints, how you think about doing research on a company. And as you make that intern more and more sophisticated, you get up to the senior MD use cases, right? An MD actually is using all of the knowledge that they've accumulated over 30 years that the AI analyst, the AI agent that you've rolled out as a firm might not have yet. That said, we see very quick uptake amongst both senior and junior folks. In a recent poll we did with a large bulge bracket bank, we saw that MDs said they saved 7.5 hours a week, and junior bankers said they saved 4 hours. And what that really means is if a senior banker is saving 8 hours, that's saving the juniors on their team a lot of time that they're not getting pinged. I think there's a few nuances to that. One is that junior use cases can be a lot harder for AI, where you want to fill out a 40-tab Excel model where everything is, ties to a T and has a citation. That final mile of delivery is very hard, right? As David just said, on Citi, PowerPoint is very hard because it requires that final mile. And so that's a lot of what these junior professionals are doing. Whereas for a senior banker, a senior investor, if you're running late to a meeting and you haven't had time to prep, even ChatGPT does a terrific job of saying, hey, get me up to speed. I'm about to meet with so-and-so, the CFO of this company. What are some strategic initiatives they should be thinking about?
Great. Manuela?
Yes.
Time for the question.
You're going to ask it, or should you just...
Do I need to ask, or are you just ready to go?
I'll follow up here. So I think that it will be interesting to understand one thing. So when I came to JPMorgan and eventually faced this financial world, which I did not know much about, everything I was going to say, oh, that's great, AI will do it. The answer was always, oh, but it's too difficult. It was always like very difficult cases, I don't know what, and it was all about showing that it was impossible for AI to do it because the humans needed to know so much. So after I always came back to my office a little bit kind of like disappointed. But then at some point, like after 3 months or something, I started talking with the business like this, where as soon as I would say something, they would say, all the difficult things. And I say, okay, just tell me the simple things, please. Just the simple ones. Keep the complex for you and give me the simple ones. And that kind of created an understanding that AI was not going to read that email that had 50 attachments with I don't know how many tables across I don't know how many documents and I don't know. So that was like scaled down what an AI could do. And eventually gave us like a lot of confidence to start. And I believe that we all have to do this because the big thing is how do we start? And start doing something trivial. I mean, it doesn't matter if the email says, what's the status of my trade ID, that's it. Great. That one I can do. And so we are in this kind of business of trying to understand what the machine can do. And then when it cannot do, well, there is always the human. It's not a big deal because the humans used to do it all. Simple, difficult, everything. So they do. And so the secret here is that the AI needs to be able to look at what was solved. And so the architecture needs to have a memory box, a box that saves things, and eventually, over time, this AI goes there, it can, retrieve and adapt, it can learn principles that it adds, it can extract examples that retrains the model, whatever it is. But the point is like this. Initially, the definition of learning was not this, give me data, label it all, feed to a neural net, and there comes the output. Learning was about improving with experience. Improving with experience. And if we don't go back to that, we build systems that will always perform 80% of the time, 82% of the time, but they will never get better. So we are in an environment in finance, which is different than other environments. We are in an environment don't forget something. All the problems get solved. All. There are always humans that solve the problems. What we cannot afford is have AI not learn from those humans that solve the problems. And there are 4 ways in which humans can actually help this AI. One is that the humans can just be observed. They do nothing. We just build code that observes where do they click here, what do they do, whatever. So we are logging, and then we learn from logs. The other one is that the human very kindly can demonstrate something, and it can say, this is how you should do, and it shows you something. It demonstrates an example. The third type is that you actually can have the human instruct every time something happens, gives you rules, gives you policies, gives you like all sorts of principles how to do. It's not the example that's demonstrated, but it's principles. And we have to have AI be able to handle rules, principles, policies. It cannot just be this obsession with examples because after all, our financial industry has a lot of principles, of rules, of all sorts of policies. So we have to be able to use that too. And the fourth way is that the human can just give feedback. No, that was wrong. Yeah, that was right. It doesn't say why. It doesn't say anything, but it just labels wrong, right, wrong, and so forth. So you have to understand that the humans play a role as a journey with this AI and these humans. And the wrong approach in our financial world is to assume that we have to know it all before we start doing the AI. So start doing, decisions on sell, no sell some stock, loan, no loan, account, no account, KYC, whatever it is, do an AI system that does the minimal. But build it such that it improves over time. And then you are reaching the sustainable architecture. Because it will, over time, collect more. And just to finish this thought, you have to understand something. We are not in a finance world, even if it's very complex, we are not finding the next prime number. We are not sending anybody to Mars. We are not doing like this, what is it, an Einstein? We don't need an Einstein. Well, look at us. We are all us. What can be done? So what I'm saying is like this. Think that the domain, always think like this. The domain is finite, is learnable. It's just too big, and probably many combinations, but it's not impossible. So just aim at having your AI system over time become better. That's it. Because you have these humans that are there. And don't only think about, this morning there was too much thing about data. Don't only think that AI is about getting data, someone who knows who labels, feeds into some machine, and there comes this model that is frozen, and you are supposed to use it. Literally, that's reducing AI to nothing. What you have is to have this AI system that is able to observe what's happening and eventually learn over time. That's what you want. Okay? So, until we do this, this is what we call kind of continual learning or continuous learning, we are still in the infancy of AI.
Yeah.
And we are dependent. I mean, the day we'll finish something, we have to start again because that thing is obsolete. Unless we build this ability for the thing to move by itself.
Now you know why JPMorgan is on the top of that.
So none of you are Einstein. None of you.
Yeah, just I want to add one more thing, and I think what Manuela said is super important.
Can I actually, and I was going to go to you because I would like for you to build upon what was just said, but put yourself in the shoes of every audience member. In their minds, my stack is a mess. I got some great data. I got some data that's not so great, to avoid a pejorative. I understand the framework that's just been articulated. It's perfectly logical. It makes sense. But at the end of the day, like, how does an institution tangibly capture that semantic, contextual data to create those learning loops? You got to build, you got to learn. It's a continuous journey. What do you actually do to start moving in the right direction?
Awesome.
I said all of that.
So you did.
There's nothing else to say. You can listen again.
You had an Einsteinian framework.
With that as a low bar. That as a low bar. Now again, what Manuela said, the important thing is to start, right? And do not use any excuse of why not to start. The typical reason, and I posted on this on LinkedIn, which is like, my data's a mess. It's not AI ready. I got to clean that up first. That's a 5-year process. I'll get back to you in 5 years. Like, do not do that anymore. Anyone who tells you that's the plan, any of the vendors who say that's the plan, ignore that. You need to start today. You need to experience what Manuela said firsthand. As much as how clearly she laid it out in those 4 steps, I trust
very clearly.
No one will really appreciate it until you've reached that point of seeing it with your own eyes, seeing the jump in reasoning, particularly in this, which we basically kind of blew past this year when the reasoning models were introduced, where a lot of what Manuela laid out became possible. Many people have not experienced, and I think you have to experience that first. And most importantly, the good news is what we help customers do is to use AI to get your data ready to do more AI. So you now have no excuses but to start. Manuela's laid out the plan. You start today. And do not take our word for it. Do not take anyone else's you read about it for it. Pick a project. If Manuela is correct, pick the easiest project you can to get started so you can see it. So you can see where it's good, see where it's bad, see that we've reached a point that you can actually have models say they don't know and what clarifications they need, which was a massive jump. No matter how much our friends are at Google were threatening physical violence to the models to make them perform, we couldn't get that to work. But the reasoning models were a major step forward, where now you basically could say, are you sure about that? What clarification questions would you need, given these set of tools, given this set of background? And now we have systems that can say they don't know. So again, that was the major thing. Don't wait. Use AI to fix data, and then pick a project where you can see it for your own eyes.
We are slightly less than 5 minutes, so we're going to go. Gabe, I'm going to start with you. Then we're going to finish out. So, in the last 12 months, we've all been on this journey. We've learned, we've failed, we've grown. The most tangible thing in your context for what you would have done differently had you known what you know now to have built better, faster, and a better pace to value?
Most important thing for us would have been, it's not about the model intelligence. It's not about how smart the LLM is. It's about the tools you give it. And if we had known that, would have been investing in those tools earlier. And to give the same analogy I gave earlier, if you have a new grad start on day 1, even if it's the smartest new grad in the planet, if you don't give them access to your tools and systems, the right credentials, the precedent examples of how they do work, they're going to be useless. And it's about building up the scaffolding and the tool set to help these models actually make an impact on your business, rather than just trying to make the models a little bit smarter, a little bit better at saying, I don't understand. Maybe better to figure out how to give the model the same tools that your human analysts do.
Very good. Thank you. Mike?
One thing I would say, it's not necessarily, we didn't know it before, but it's something that we need to acknowledge. We've gone from, this is a domain where you had a small group of practitioners in the corner, right? In a large organization that would understand it, but still is abstract for the large part of the organization, to something that is accessible for the entire workforce. But you can't just leave it at that. You have to really invest in the people. It's not about actually people giving problems to the experts. It really is actually empowering the people that you have. So that's why we think it's a completely different model that you need to take on in this part. Of course, you're going to need the experts. Of course, you're going to need the data scientists and the PhDs to really solve on the frontier. But if you don't empower your entire workforce, if they don't necessarily know it in a tangible way, how it can help them, in day to day, you're not going to unlock the potential that you see. So that's what we, really believe in. And we talked about Eliza having the entire from 99% of the people on it, building muscle, having 40% of the people actually building agents. Not all of them may be great, but now you actually have understanding. If this thing is not something you read on paper, you've done it. You see, that would go a long way. So that's a different approach in unlocking value than this group of experts actually solving the entire problem.
Very good.
I'll go quick.
About a minute, sir.
Go narrow. It's always tempting to go broad, build generic kind of solutions. Do not do that in this space. It is tempting. Avoid a temptation. We fell for that temptation. We spend a bunch of time and realize what is the core use case we can focus on. Go narrow, go deep, get it. Go broadening will happen later. And I think, and figure out what is your kind of pain point and figure out how to get to the end point, and do not get distracted by general purpose solutions.
The last word is yours.
Okay, well, I'm going just to explain one more thing. So somehow we kind of discussed all these about agents and all, the humans, the role, and so forth. But what we need also to embrace is that agents, one way or another, will need to talk with other agents. And this concept of talking with other agents is because we are not going to build one AI system that knows the weather, knows the hotels in Paris, knows the flights, knows everything. So we have this. So the same way that for an agent we break into little skills, we also capabilities and problem solving is going to be broken into multiple agents. The only problem is the following. We need to understand that the agent we write and asks weather.com for whatever or something, we don't know what the other agent does. It's a black box for us. The only way to go to the other agent is through a request, a question, and the thing answers. So think about this complete distributed way of thinking about AI. Every single capability belongs to some kind of agent. As humans, because humans, we assume they will do it as we do. But these are machines. Who knows how they are going to compute the weather? We don't even know if they actually tells us the right weather. So the agent needs to have the skills, the memory, look at the humans, how they solve, and somehow learning from experience what these other agents do. You have to learn to trust them or not trust. So you have three choices of asking about the address of this customer. And now you ask this, random, choose one of them. And now you go, and after all, this is wrong. Well, save that guy does not give you the right answer. Fine. Next time you go somewhere else. So an agent has the memory, has the feedback from humans, and a model of all the others that it kind of talked with. And so now it has this computer code is very intelligent. It's not a tool. It's something that's like building all this knowledge from experience. And now you use these to make your decisions. Who do I ask for? Do I trust more? And so forth. So you need to embrace the completeness of building this agent in a multi-agent system.
Manuela, we got to end it there.
There you go.
All right. A round of applause for the panel, please. Thank you.